Hello, I'm Mr. McBrien, and this is the Robotics Club breadboarding movie. So, we might ask how we can easily test prototype designs without having to do a lot of permanent soldering. We might want to connect a large amount of components without making a printed circuit board. We might want to make very fast temporary connections to test components. The breadboard is our way of doing this. And this presentation is intended to explain what a breadboard is, identify the reasons for using a breadboard, and then review some guidelines and tips for breadboarding that'll be most effective. Okay, so first off, what's a breadboard? It's sometimes called a proto board. It's a reusable platform for quickly building short-lived temporary circuits. The way it works, it's a pretty straightforward thing. The breadboard is just some plastic that covers over a bunch of springs that conduct electricity. And the springs are intended to grab hold of a wire of the appropriate gauge and allow us to essentially avoid soldering between those wires. And the holes in the top of the breadboard are designed specifically to allow us to connect together different wires using those spring clips. So I invite you to have a close look at the cutaway view on the bottom and think about what that implies to the circuits that you're going to build. And you may want to return back to that picture a few times as you try to grasp the way that a breadboard works. So, at any rate, the wire that goes into those holes will be electrically connected to anything else that spring is connected to. You can think of those springs then as jumper wires. Okay, so we saw the cutaway. Now let's have a look at the breadboard connections. So a standard breadboard then will have a spring underneath it corresponding to those red lines on the screen. So there's typically one or two long lines that run the length of the board. Those are intended for power and for ground. And then there are vertical lines that are intended to connect together two or more components. And notice that there's a split in the middle of the board. And this serves, well, two purposes. But typically we'll run integrated circuits across this split. So again, when we're breadboarding, it takes a lot less time and money to build a circuit than it does to make a printed circuit board. So printed circuit boards, we won't be using them for our robots because they'll be fairly temporary designs. But they're how you would long term, if you wanted a robot to work for months or years, you would create a PCB. So what we instead use we may have breadboards inside our robot, our final robot. Probably not. But we might have breadboards on our prototype robots before we solder all the connections. And we'll use that in order to make sure that our system is the way it wants to be. So the great thing about breadboards is that you can swap out different resistors, capacitors, etc. in very, very quickly while you're testing your designs. And you can also make all kinds of measurements very easily because the board is exposed, and it means that you can measure voltage, current, resistance very easily in your system from various points of your circuit. So how do we breadboard well? Well, there's some guidelines. First off, use as few jumper wires as you can. make the majority of the connections between the components themselves. So connect them up to one of those spring clips we saw directly. Don't use more jumpers than you need to. Similarly, you want to keep the jumper wire short. The longer the wires are, the harder it is to figure out what's going on. And you also want to breadboard a circuit so that it looks very close to the layout of the schematic diagram. And this makes troubleshooting it easier as well. We won't use a lot of IC chips, integrated circuit chips, in our work, but we will use one in one of our test circuits. You'll put those in the middle of the breadboard typically. And what you want to do is when you're working from the schematic to set up the breadboard, you want to kind of work. I typically work clockwise around the circuit, checking off each connection as I go. You want to have lots of leads ready to go, cut to various lengths, so that you can just grab them and keep working. You don't want ones that are too long and might touch and short each other out. And when it comes to circuits where they're fairly complicated, you may want to have a partner check your circuit for errors before you put power on it. In terms of wire colors, the builder can communicate to reviewers what's going on by using wire colors. And incidentally, in a big project, you're communicating with yourself. So where possible, use colors to communicate function. In particular, the ones that are virtually always used. Use red and orange for positive. Use black or blue for negative. So you may want to, if you've got a really complicated circuit, you may have various other colors to communicate other functions of those wires. So as a few examples, you can see in this case we've got a lot of very long wires with jumpers and things, and you can easily imagine alligator clips all over the place. You can imagine that it's very easy for us to see one wire shorting out against another one. And B, it's almost impossible to understand what's going on in this ridiculous circuit. So it's a little bit better one. Of course, this is doing a lot less. But this is an example of a pretty good prototype circuit. I wouldn't call this excellent, but certainly more than good enough. We can see there are very few wires used, only a couple. Most of the red wires are used exclusively for power, and the black wires are used exclusively for ground. So you can see this is something where we can easily see all the components and what they're connected to. And here's a more complicated example of what I would call a very good implementation. You can see that all of the wires now run straight. The electrician has bent the wires where they've got a little extra length, keeping them at 90 degrees so that they're not all up above the board. The colors have been grouped, presumably for some specific purpose. It's not necessarily easy to see what that purpose is in some cases, but this is because we haven't gone through and looked at our circuit diagram. At any rate, there are nice short wires. It's tidy. It's easy to see what's going on. So for some more tips on breadboarding, you can have a look at the reference below. And I'd invite you to move forward to breadboard your first circuit now. Go ahead and obtain the materials and get to work in the classroom. Thank you and have a great day.